Gigabit Ethernet. We need for an even higher data rate resulted in the design of the Gigabit Ethernet protocol, which is having 1000 Mbps speed. The IEEE committee calls the standard 802.3z. The goals of the Gigabit Ethernet design can be summarized as follows. First one is upgrade the data rate to 1 Gbps. Second one, make it compatible with standard or fast Ethernet. Third one, use the same 48-bit address. Fourth one, use the same frame format. Fifth one, keep the same minimum and maximum frame lengths. Sixth one, to support auto negotiation as defined in fast Ethernet. See, in this first one, max sublayer. A main consideration in the evolution of Ethernet was to keep the max sublayer untouched. However, to achieve a data rate 1 Gbps, this was no longer possible. Gigabit Ethernet has two distinctive approaches for medium access. One is half duplex and second one is full duplex. Almost all implementations of Gigabit Ethernet follow the full duplex approach. However, we briefly discuss the half duplex approach to show that Gigabit Ethernet can be compatible with the previous generations. See, full duplex mode. In full duplex mode, there is a central switch connected to all computers or other switches. In this mode, each switch has buffers for each input port in which data are stored until they are transmitted. There is no collision in this mode as we discussed before. This means that CSMA CD is not used. Lack of collision implies that the maximum length of the cable is determined by the signal attenuation in the cable, not by the collision detection process. In the full duplex mode of Gigabit Ethernet, there is no collision. The maximum length of the cable is determined by the signal attenuation in the cable. Half duplex mode. Gigabit Ethernet can also be used in half duplex mode, although it is rare. In this case, a switch can be replaced by a hub, which acts as the common cable in which a collision might occur. The half duplex approach uses CSMA CD. However, as we saw before, the maximum length of the network in this approach is totally dependent on the maximum frame size. Three methods have been defined. First one traditional, second one carrier extension, and last one frame bursting. First one traditional. In the traditional approach, we keep the maximum length of the frame as in traditional Ethernet 512 bits. However, because the length of a bit is 11100 shorter in Gigabit Ethernet than 10 Mbps Ethernet. The slot time for Gigabit Ethernet is 512 bits into 11100 bits, which is equal to 0.512 GIS. The reduced slot time means that collision is detected 100 times earlier. This means that the maximum length of the network is 25 meters. This length may be suitable if all the stations are in one room, but it may not even be long enough to connect the computers in one single office. Next one, carrier extension. To allow for a longer network, we increase the maximum frame length. The carrier extension approach defines the maximum length of a frame as 512 bytes. This means that the maximum length is 8 times longer. This method forces a station to add extension bits to any frame that is less than 4096 bits. In this way, the maximum length of the network can be increased 8 times to a length of 200 meters. This allows a length of 100 meters from the hub to the station. Last one, frame bursting. Carrier extension is very inefficient if you have a series of short frames to send. Each frame carries redundant data. To improve efficiency, frame bursting was proposed instead of adding an extension to each frame. Multiple frames are sent. However, to make these multiple frames look like one frame, padding is added between the frames, which means the same as that used for the carrier extension method, so that the channel is not idle. In other words, the method deceives other stations into thinking that a very large frame has been transmitted. Physical layer. The physical layer in Gigabit Ethernet is more complicated than that in standard or fast Ethernet. We briefly discussed some features of this layer. Let us see topology. Gigabit Ethernet is designed to connect two or more stations. If there are only two stations, they can be connected point to point. Three or more stations need to be connected in a star topology with a hub or a switch at the center. Another possible configuration is to connect several star topologies, or let a star topology be part of another as shown in figure 22 that on the screen. Let us say implementation. Gigabit Ethernet can be categorized as either a 2-wire or 4-wire implementation. The 2-wire implementations use a fiber optic cable or STP. The 4-wire version uses category 5 twisted pair cable. In other words, we have 4 implementations as shown in figure 23 that is on the screen. 1000 base T was designed in response to those users who had already installed this wiring for other purposes such as fast Ethernet or telephone services. See, encoding. Figure 24 shows the encoding decoding schemes for the 4 implementations. Gigabit Ethernet cannot use the Manchester encoding scheme because it involves a very high bandwidth. The 2-wire implementations use an NRZ scheme. But NRZ does not self-synchronize properly. To synchronize bits, particularly at this high data rate, this block encoding prevents long sequences of zeros or ones in the stream. But the resulting stream is 1.25 Gbps. Note that in this implementation, one wire means a fiber or STP is used for sending and one for receiving. In the 4-wire implementation, it is not possible to have 2 wires for input and 2 for output because each wire would need to carry 500 Mbps, which exceeds the capacity for category 5 UTP. As a solution, 4D PAM5 encoding is used to reduce the bandwidth. Thus, so all 4 wires are involved in both input and output. Each wire carries 250 Mbps, which is in the range for category 5 UTP cable. Just look at the summary of Gigabit Ethernet implementation in table 3. You just look at characteristics and 1000 base SX, 1000 base LX, 1000 base CX, 1000 base T. And the characteristics are media, number of wires, maximum length, block encoding, line encoding. You can observe all these differences between all these cables. See, if you remember this table, you can easily write if they given any kind of question regarding Gigabit Ethernet, you can easily write. You just remember this table, then you can easily write whatever that. And in table 4 also is there. In the table 4, another characteristics is there, media and maximum length. This is also you need to remember.